So guys, we are going to do maths paper 2 for grade 10. Okay, so hopefully we'll be able to touch on everything that is maths paper 2 related, because I can't just do the one topic that you may possibly want, but just want to cover the important bases of paper 2, grade 10, because I have it on good word that some of you are writing tomorrow. So let us get this party started. Okay, so in paper 2 we have stats, we have analytical, we have a trig. Hello there, we have trig, and we have Euclidean. So those are basically the topics that will feature in paper 2, and I'm guessing measurements as well, which is part of Euclid. They basically also include that. Now obviously in this term already you guys have done, alright, trigonometry functions are part of trigonometry, so functions feature there. Alright, I'm not writing it as a separate topic. Trig includes the simplification of trig, triangles, and everything else. Trig functions are also there. Measurements you guys did. Alright, you guys just did measurements at your schools. So for people to say they want me to do measurements, which is something that they just recently did, I would be mind-boggling to me, to be honest. Alright, so I have it under good faith that measurements is something that you did. You did it just recently, you see. So the whole goal of this live is not for me to go and do what you were supposed to have done at your school. I'm here to revise paper 2, alright, not with any specific focus on just something, but just to give you guys an overall overview of the things that you ought to know, and also then to see if we can't do specific topics, because obviously the whole point and whole goal of revision is to sort of bring back some of the things that you should have done. Let's see. I see you are saying, the question is, how could you have not done it at school? And then there's a term test that is usually written in term 4 that is supposed to include measurements. So how can it have not been covered at your school? Because there's a term test that's supposed to have measurements. You see, that's something that is really, really shocking if you ask me. Okay, because these are topics that are supposed to have been covered. Mind you, measurements, I actually did I did a live on measurements, and I posted the video online. So my question is then, did you get the chance, or did you take the time to even check out the live session I did on measurements on the channel, and then if not, then I don't know, how can at your school also, how can they include measurements as part of the paper, but it's going to be tested in the exam? I see that you're saying yourself was focusing on grade 12, didn't come to the class, but then the thing is, it means that you guys have an argument towards your sir as far as this topic is concerned. Okay, all right, but nonetheless, we'll just have to proceed. So as I said, guys, we'll take one topic at a piece, all right, because I am not here to really, like I said, do anybody any justice than to actually make sure we cover maths paper 2 content, not for just a particular individual, but so that everybody that's here can sort of benefit from actually attending the live. So in stats, guys, there are two things. There's in grade 10, there's ungrouped data, then there's grouped data. So for grouped data, I'm sure you will see that they usually will have a table, and they call it a frequency table, where they will have a class interval of some sort, then they'll have a frequency here somewhere, and then you have the obligation to try and find the midpoint of each class interval. Then somehow you have the frequency times midpoint, which will then assist you in being able to calculate something that we referred to as the mean. All right, so yeah, that is grouped data. All right, then there's ungrouped. Ungrouped is just if I give you, let's say for instance, I say a class of 4 students wrote a test out of 10. One got 5, the other one got 6, the other one got 8, and the other one got 9. Let's just say this is, let's say this is class A. Let's say there's another class, okay, that wrote a test. There were 3 learners in that class. The one got 5, the other one got 7, the other one got 10. Okay, so ungrouped data is just data that is just like thrown there, you know. It's listed, there's no class interval, it's not grouped into specific class intervals. So ungrouped data is just data that is there, it's listed data. Okay, all right, so 5, 6, 8, 9, 4 learners that are part of a class wrote a test out of 10, and basically there's a lot of things that we can then read from that data. So underneath the topic of stats, there are what we call measures of central tendency. Okay, those measures of central tendency include what we refer to as the mean, 1. Okay, and mean is basically the sum of all the data values over the number. Okay, the sum of all the data values over the number of how many data values you might have. Okay, that is basically your mean. Then you have what you call your median. Median is like the middle value. The middle value of arranged data. So the data must be arranged, and preferably in ascending order. By ascending order, we mean from smallest to biggest. In ascending, sorry, not data, but in ascending order. So your median is your middle value of arranged data in ascending order. Then 3, your last measure of central tendency is what we call mode. And mode is basically the number that appears the most. Okay, yeah. So we have mean, sum of all data values over the number of data values. Median, the middle value of arranged data in ascending order. You have your mode, that basically is the number that appears the most. So mode most. Okay, those are your measures of central tendency. Then you have, remember, your measures of dispersion. Okay, it's a measure basically of how spread out our data is, and basically we have under measures of dispersion, we have 1, range. Okay, that is maximum minus minimum. This is for grade 10, guys. This is grade 10 paper 2. Okay, but obviously this would be introduction for grade 12, if you know what I mean, because the foundation for grade 12 is in grade 10. Range, that is your maximum minus your minimum. Interquartile range. Interquartile range, guys, or what we call your IQR, is your Q3 minus Q1. What do we mean by Q3? By Q3, we mean your upper quartile. And then Q1, we mean your lower quartile. Okay, so that's Q3 minus Q1, that's interquartile range. Then 3, we have what we call semi-inter quartile range. Semi-interquartile range, guys, is basically Q3 minus Q2 over what? Over 2. So that is your SIQR, your semi-interquartile range. So these are what we call, guys, the measures of dispersion. Okay, measures of dispersion. And then basically from that, you know, there's a wide range and variety of calculations that we can do, but we have something here that we call the box and whisker diagram. And in that box and whisker diagram, guys, okay, you would have in that box and whisker diagram what we call a 5-number summary. Okay, and that 5-number summary will simply include what? It will include, in your data set, if you have it, you'll have your minimum value. Your Q1 value will feature here. Q2, or your median value, would feature there. Q3, or your upper quartile, would feature there. And then lastly, your maximum value. And this here would be your number line, which would be scaled, all right? A scaled number line, whereby you will be able to feature and show all your values, all right, on this number line. This is a box and whisker diagram, and it is a tool by which we are able to summarize our data using the minimum, which is from the 5-number summary, Q1, which is your lower quartile, Q2, which is your median, Q3, which is your upper quartile, and your maximum value, all right? And that basically comprises what we call your 5-number summary. Okay, so that's kind of like a brief, guys, for ungrouped data. On the other hand, like I said, grouped data, guys, is usually represented in class intervals, and we usually use a frequency table to basically represent our grouped data. Okay, so class intervals, most class intervals, they will use maybe inequalities to sort of like represent the class interval. Maybe from 0 to 10, they'll be collecting a certain set of they'll be checking a certain aspect in that class interval, and then they'll be saying how many values are between 0 and 10, and then we list how many values are between 0 and 10. We write how frequent do we see values between 0 and 10, and so it goes, all right? And from this, we basically are able to get estimates or approximations. What type of approximations? Okay, this is grade 10. This is not grade 11 or 12. So you're asking a question about cumulative frequency, and that's not in the scope of what I'm doing right now. So the learners that are here don't have an idea of what you're talking about. They'll only know what you're talking about in grade 11. Guys, this is grade 10 maths paper 2, not grade 12 or 11. Okay, but it is basics or foundation for grade 11 and 12. So we are able to calculate what we would then call your estimated mean, all right? Your estimated mean, okay? And very good lunch. Go try Kevin. Kevin will help you out a lot. Kevin, Maths and Science, is the man. So for your estimated mean in grouped data, you have to find your frequency. You then have to find your midpoint of each class interval. Then you multiply each row, get your sum total of the frequency times midpoint total. And then basically, as you calculate your estimated mean, your frequency times midpoint total features here in the numerator, and then you divide it by your frequency total. So your sum of the frequency times midpoint total divided by your frequency total will help you calculate your estimated what? Mean. Estimated mean for grouped data, all right, which is very much different from what we're referring to with ungrouped data when we want to calculate mean for grouped data. Okay. Yeah, so I hope we are clear. Yes, I'm covering the concept. I'm going to question papers, but first I'm just making sure that we are in the same page with the concept. So that's the first thing. Secondly, there's something that we call modal class. What is modal class? Modal class is basically the interval with the highest frequency. Okay, if for some reason they ever ask you to calculate the estimated mode, then the midpoint of the interval with highest frequency will give you that. I repeat, if they ever ask you to calculate estimated mode, then first go find the interval with the highest frequency. When you locate that interval with the highest frequency, you then calculate the midpoint of that interval with the highest frequency. It will give you the estimated mode. 3, median, interval where the median lies. Okay, and furthermore, the estimated median. Okay, I guess through an example, I'll be able to, through an exam example, to basically show you how do we find where the interval, where the median lies, and then furthermore, how do we actually find the estimated median? Okay, yeah. So yeah, because the estimated median will basically lie where the interval for the median would actually lie. So I'm actually going to go into that when that time comes closer. So this is my summary, guys, for statistics. All right, and stats in a typical exam paper has marks. They might not be that high or significant, but let me tell you this, the marks are basically marks that we cannot afford to not achieve or get. Okay, so let's come here very quickly. Sorry. Just grab something here. Let's grab something here. Okay, let's check out this paper here very quickly. Okay, the question says 19 girls, grade 10s. 19 girls were required to complete a puzzle as quickly as possible. Okay, just so you know, if you are in grade 12, guys, I saw that Lungis Ngosi, one of the YouTubers, is actually live right now and he's doing a grade 12 paper on his YouTube page. He is live doing a grade 12 question paper. I think it's a grade 12 question paper. So if you want to go to a live, you are in grade 12 and you'd like to maybe fast track progress in your learning, I think when I saw him live, he was doing trigonometry. He's very good, so do check him out if you can. 19 girls were required to complete a puzzle as quickly as possible. Their times in seconds were recorded and are shown below. Guys, please, when you read something, understand first this scenario so that when you answer the question, at least there's sense in what you are doing. 19 girls were what? They were required to do what? To complete a puzzle as quickly as possible. So you can imagine these 19 girls, they are pushing to complete a puzzle as quickly as possible, all of them. Then their times in what? In seconds were recorded and are shown below. So one of the girls, he completed that puzzle in 17 seconds, the other 24, 16, 18, 29. Each girl completed the puzzle at a different time. Do you see that? The first question says, arrange the times in what? In ascending order. For how many marks? For 2 marks. Now, you may think that's Isoka. Arranging. Yeah, guys, I'm hoping you know that arranging is not that difficult. You shouldn't have a problem with arranging these things in ascending order. It should be straightforward. But let's be careful that we make sure that we record all the times. So if we look here, what is our lowest time? Because if we're arranging in ascending order, we must start with the lowest number to the biggest number. If they had said descending, then we'd start with the biggest number to the smallest. So the smallest number that we have here, I'm sure you guys can see, we have 17, 24, 16, 18, 29, 17, 19, 15, 14, 22, 18, 19, 16, 23, 20, 21, 19, 24, 21. Smallest number I see here is 14. So I'm going to cross out 14 and then I'm going to go to my answer sheet and write the first number, 14. Do you see what I mean? Then I look, is there another 14? No, there isn't. So after 14, because that's my smallest number, I'm looking for what? For 15. 15 is my next number. I cross it out, okay? And then I write 15. Okay, I look, is there another 15? Doesn't seem like it. 16 is my next number. I cross out 16. There's one 16. There's another 16, and every time I cross out, I write down the number. Why am I doing that? Why, when I write down a number, am I crossing out? It's because I want to make sure that when I'm done, all the numbers have been recorded. Does that make sense? So then that's 16, then 17, it comes in there. 17, you must come as well. Okay, doesn't seem like there's any other 17. 18, yeah, 18 is there. So we record it there. 19, 18 again? No. What about 19? 19 is there as well. We have how many 19s? 1, 2, 3. So I'm going to write down 1, 2, 3. 3 19s. Okay, is there other number that's 19? No. 20 do we have? Yes, we have 20. There's 20. 20. Yo, very good. Thank you, Content Crafter. Content Crafter is like, you forgot 18 on the left. Now imagine if I was not doing the crossing out, right? The problem or the danger there is that not doing the crossing out, even when I'm done, because when I'm done, even if I had missed the 18, I would have picked it up. Oh, the 18 I forgot. Does that make sense? Then I would have gone back and actually filled it in where I actually had left it out. So I'm gonna put that 18 right there. Okay, yeah. Okay, then I'm going to cross it out so as to indicate that it's gone. Okay, after 19, yes, I have 120. I have only 120, it seems. I don't have another 20. Sweet. Then it's followed by 21s. I have 2 of the 21s there, so I'm going to write down the 2 21s. Then 22, that also must go. 22 there. And then it seems like I have a 23 and a 24 and a 24. So I'm going to say 23, 24, 24. Then we confirm the numbers if there are 19 of them, because there are 19 girls. So let's count the numbers if there are 19 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh no. 1, 2, 3. Who did I? Oh, 29. You see, look at that. You see, I didn't cross it out. Now I counted there are 18. Something's wrong. So 29, I forgot to write the 29. So we cross that out. We write 29. Okay, now I know there are 19 numbers. I mean, there are really 19 numbers because I've counted, I've confirmed, I've checked. Let's move on. Identify the median time taken by the girls to complete the puzzle. The what? The median time. What is median? Okay, guys, we said median is the middle value. Okay, now when my data set, guys, is odd, the median sticks out like a sore thumb. Whenever my data is odd, meaning there are 3 numbers here, that means my data set is odd. That means my median is available and we can see it in the data set. Okay, so there are 3 numbers, so that means 1 1 on either side. The third number is in the middle. Okay, even if there was 5 numbers, it would mean 2 on the right, 2 on the left. The middle number is the 5th number. It's in the middle. It is visible. So for an odd data set, my median is always visible. I can see it in plain sight. But if my data set is what? Is even. I have an even data set. What do I mean by that? How many numbers do you see here? There are 1, 2, 3, 4. That means there's an even data set. Then it means that to get my median, I'm going to take my 2 most middle numbers. And what am I going to do to them? Okay. What am I going to do to these 2 numbers? I'm going to add the 2 most middle numbers to get my median. Going to add these 2 numbers, 6 plus 8. Then I'm going to do what? Divide by what? By 2. Why do I do that? It is because, guys, that median is supposed to feature there midway, So 8 plus 6 would be 14, and 14 divided by 2 would give me 7. So that would mean that indeed my middle number is not visible because my data set is even. Okay, so guys, this is, like I said, this is grade 10. Okay, I'm doing maths paper 2 for grade 10. This is revision for grade 10, not for grade 12. If you want grade 12 revision, please, guys, Lungis Ngosa, I think, is doing grade 12 revision on his YouTube channel. He's live right now. I would advise you to steer on there. It would help you out a lot. So I hope you get the difference. Always, guys, for an even data set, your median will not be one that you can just pick out, but you need to go to your 2 most middle numbers. There's always two most middle numbers for an even data set. You take those 2 most middle numbers, you add them, you divide by 2, then you'll be able to locate your median. I hope that's clear for us. So for an odd data set, your median is visible. It sticks out like a sore thumb. But for your even data set, the 2 most middle numbers you add together, you divide by 2, you are able to get your median from there. Okay, I hope that's clear. So now, remember, we had what? 19 girls. How many times did we get? We got 19 times. 19. Does that make sense? So that means, guys, if we have 19 times, okay, then we are going to have 9 on one side. This is an odd data set. We are going to have 9 numbers on this side and 9 numbers on the other side. That gives me 18. Then the middle number, will be the 10th number in this data set. So I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is there, guys. The 10th number. All right. Because 9 numbers on the left, because this is an odd data set, 9 numbers on the right, my middle number is 19. So that is my median. So if they want me to identify, and that's what they said in the question, identify the median time. Why are they saying identify the median time? They know that because I have an odd data set, it should be visible, the middle number. It should just be there in plain sight. There's no calculation needed. So that's why they are saying identify the median. Because you are dealing with 19 numbers, and 19 numbers means we have an odd data set. And where is the middle number for an odd data set of 19 numbers? It means that it is located there. It's the 10th number because 9 a piece means 18. So there's 1 number left, which makes 19, and that is there. it is the number 19. Guys, it's a coincidence that it's the number 19. It doesn't mean if there are 19 numbers, it will always be, the median will be 19. No, it's just a coincidence with this situation, okay? I hope it's clear, that one. Okay, so we have 3 marks so far and we're very happy. 1.3. Determine the lower and upper quartiles for the data. Determine the what? The lower. So in other words, they want Q1, and the upper quartiles, they want Q3 of the what? For the data. So remember, guys, our lower quartile, let's start there with the lower quartile. Okay, when we define lower quartile, we are saying, what is the lower quartile? We look at the lower half of our data set. Remember, this is the median, it's 19, it's been identified. So now what we do is we look at the lower half of our data set. We start with that 19, that 18, this is basically the lower half, the 9 numbers that are left on the left. This is the lower half. We then need to go and find the median, the middle number of the lower half. Does that make sense? The median of the lower half of our data set. So what did I say, guys? There are how many numbers? There are 9 numbers. So that means this is an odd data set. So that means the middle number is visible. Okay, 4, 4, and then the middle number should be there. So let's count 1, 2, 3, 4. That's 4, and then 4 on this side. 1, 2, 3, 4. That means our median for the lower half. The median of the lower half is Q1. What is the median of the lower half? It is 17. Okay, I repeat. What is the lower quartile? The lower quartile is the middle number of the lower half of our data set. Why do we know that this is the lower half? It's because we were able to identify the median, that it is 19. The lower half, the lower set of values that we have are the ones that start here all the way to 14. So it is not including this median that we had gotten, but it's all these numbers. How many numbers do we have? There are 9 of them. Since there are 9 numbers, we are going to identify the middle number of these numbers that are in the lower half. That gives us Q1. So Q1, guys, the lower quartile, we would say the lower quartile, or Q1, is equal to 17. That's what we would say. Okay. Then, like I said, if you go there to the lower half and you discover that the numbers are not odd but they are even, then you must do what? You must find the 2 most middle numbers, add them together, you divide by 2. Okay. If these numbers that are in the lower half are an even data set, you find the 2 most middle numbers, mutawung, you add them together, you divide by 2, then that would be your what? Your Q1 for the lower half. Okay, so you must not be lost even if that is like that. Let's go to the upper half, okay, to get the what? The upper half to get the upper quartile. So we start from this number 19 all the way to 29. These are 9 numbers again. We have an odd data set. This odd data set, guys, all right, that has 9 numbers. It will be 4, 4 on each side. 4 plus 4 is 8, right? Then the middle number will be the 5th number. So let's count 1, 2, 3, 4, 5. So that means 22. Q3, the upper quartile, which is Q3, is actually equal to what? It's equal to 22. Okay, no waste of time. No waste of time at all. Okay, so I hope that is clear for all of us. We are good, you know. Now let's come here. Draw a box and whisker diagram to represent the data. Draw a what? A box. And a what? Whisker. Diagram to do what? To represent the data. Remember guys, in order to draw box and whisker, we first need to have our 5-number summary. Now, already we have aspects of the 5-number summary, because Q3 we have is 22, Q1 we have is 17, and then remember in 1.2 we did identify the median, and we know that the median of the entire data set is Q2, and we found that it is 19. So the only thing that we are left with now is the what? It's the minimum and the maximum. So the minimum of this data set, remember the lowest number that we have in this data set is what? Is 14. The maximum that we have for this data set is what? It's 29. So what do I have here? I have minimum, I have Q1, I have Q2, I have Q3, and I have the maximum. This is what I call my 5-number summary. And using this 5-number summary, what can I do, guys? I can now have confidence to draw the box and whisker diagram. But remember now, when you draw that box and whisker diagram, my fellow beloved grade 10s, you must make sure that you now actually produce a scale. So you must have a horizontal line. You use your ruler, guys, and since the lowest number is 14 and I know the highest number is 29, I'm going to use my ruler so that I can measure, so that it's equally spaced. I'm just wondering, what if I go up by 2s? 18. Okay, if I go up by 2s, all right, 14, then 16, so you use your spacing, maybe your ruler, guys, your centimeters, you make sure 14, 16, but it must be evenly spaced. 18, 20, 22, 24, you will use your ruler, guys, evenly spaced. 26, 28. Now then you write 30 because you're going up in what? In 2s. So your scale must be evenly scaled. You must make sure, if you are counting in 2s, then of course in the middle here, that's why I say you use your ruler and you measure properly. So I would basically use my ruler, maybe that 14.5, that would be my 15 mark, 16, 17, 18, and so it goes. You know what I mean. But it must be a scaled axis, so that when you come now and you draw your box and whisker, remember your minimum is 14. So this is where your box and whisker starts. Your Q1 is 17. 17 is midway, Q2 is 19. 19 is midway between 18 and 20. You see, my Q3 is 22. So 22 I have exactly there. And then last but not least, my maximum is 29. So 29 is between 28 and 30, midway, right? We connect the whisker, we write, make sure our box is good. All right, guys, I'm using freehand because my other arm is holding my phone. And then we connect that long one. Okay, and you can see the 14 is directly there, the 17 is directly there. So I know this is min, this is Q1, that is Q2, that is Q3, and that is maximum. And you can see clearly, 29 is my maximum, 22 is my Q3, 19 is my Q2, Q1 is my 17, minimum is my 14. You see? Yeah. I hope you guys understand this. I hope you understand this. The next question says, calculate the interquartile range for the time taken by the girls. Calculate the what? The interquartile range. Okay, what is interquartile range, guys? Now, when they want us to calculate interquartile range, what do they mean? Okay, remember from the formula, IQR, interquartile range, okay, is what? Is Q3 minus Q1. Make sense? Q3 minus Q1. So Q3 minus Q1, we already have Q3, it's 22 moles. What about Q1? Q1 is 17 moles. What's 22 minus 17? Oh, it's 5 moles. So IQR, high, interquartile range, high, straightforward, guys. Okay, next question. What is the mean of the, what is the mean time? What is the mean time that the girls finished the puzzle? What do they want now? They want the mean time. The mean time. The mean time. Okay. So remember, guys, when we are calculating mean, we have mean means the symbol we use for mean is X bar. X bar. This X bar means the sum total of all the data values that you have, all 19 of them, you add them together. This is a symbol that stands for sum over n, meaning the number of data values. So we would basically do what? We would take all those data values that we have listed here, we add them all together. All right, you take the time, guys, you add all those data values together, you get the sum, and then you divide it by the number of data values. You take that sum. Okay, so I'm hoping someone is busy there adding for me, and then can tell me what the sum total is so that I can insert it there. You know, you cannot run away from using that calculator and having to put in all those data values, guys. Whether you decide to use the calculator as your method or not, you cannot avoid it. It's unavoidable. Unless you have a brain like a computer and you can add all those numbers in your head and you can get the number. I know some people can do that. There are amazing people in this world that we live in. I am just not one of them. My brain, it doesn't work like that. Okay, it don't work like that. Okay. Okay. Right. So that total at the top there gives us 372, which we have to divide by 19. You got 375. Mutawung, Angel, you got 375. Okay, it can't be over 10, remember? It has to be over 19. Okay, so let's check. Your data value should be 17, followed by 24, followed by 16, followed by 18, followed by 29, followed by 17, followed by 19, followed by 15, followed by 14, followed by 22, followed by 18, followed by 19, followed by 16, followed by 23, followed by 20, followed by 21, followed by 19, followed by 24, and then last but not least, 21. I get 372, not 375. Yeah, you can come. Come. 19, round off to 2 decimal places, 19,58. Okay, yeah. So if you have 19,578 and they say round off to 2 decimal places, of course you're going to round off. 8 says 1 to 7, you go up by 1. Okay, then that is the mean time. Then they are asking us, what is the mode time? What is the mode time? So what we are going to do, we are going to look at which number appears the most. Okay, which number in our data set appears the most. So I was looking at this data set. 16, no. 17, that's twice, right? 18 twice, 19 3 times, 20 once, 21 twice, 22 once, 23 once, 24 twice. So it seems like the number that appears the most is 19. So when we say the mode, we would definitely say 19 seconds. Okay, guys, that pretty much wraps that up. Okay, that pretty much wraps that up. So that's just a bit of a taste in our application of ungrouped data. Okay, ungrouped data. Had they asked us to calculate the range, we would have taken the maximum value minus the minimum value if they had asked us for the range. Had they asked us to calculate the semi-interquartile range, we would have taken Q3 minus Qt and divide by 2. We drew a box and whisker. Yo, you see? So it's nice. And guys, here's another thing. Box and whisker. From minimum to Q1, this is 25% of our data that has been given to us. Q1 to Q2 is another 25% of the data. So if you were to ask from minimum to Q2, what percentage of the data is that? It's 25 plus another 25. So that's 50% of the data from the minimum to the what? To Q beautiful 2. Wangoho, I got you there. It was what is the mean? We were supposed to calculate the mean. Okay, the question was to calculate the mean time that the 19 girls were able to finish their puzzle. So we took the sum of the data values, we added them all together, and we divide by the number of data values, it's the number of girls. So we got 19.58 seconds as the answer. Sorry, that's S to just show seconds. Okay, then we asked the mode. The mode means the number that appears the most. We see in that data set it's 19 that appears the most. So please guys understand this. So this is another 25% as well from Q2 to Q3, and then from Q3 to Q to maximum, this is another what? 25%. Okay, so my grade 10 learners, let's understand that and be cool with that, so that statistics, we don't lose those marks. Let's go now and look at questions related to grouped data. So when we have class intervals, then we are no longer dealing with ungrouped data, but we are dealing with what? Grouped data. So let's read. The weight of parcels couriered by a courier company. Guys, nowadays, there are so many people that are using this system of being able to get things all across the world. All right. Yeah, what's very good as well is the spirit of entrepreneurship I am seeing amongst people, even learners, some of them who are still in high school. They are not waiting until they get employed or waiting until they work for someone. Some kids are actually starting to have the spirit of entrepreneurship. And so they use the courier system. For instance, I see people selling, clothes, sneakers, Galaxy Boy, and all sorts. And they are using a certain courier system to be able to get things from one place to another, so that when a customer of theirs wants something, they can get that thing to them, via a courier system. So the weight of parcels couriered by a courier company in 1 week are shown in the table. You see, the weight of parcels couriered by what? By a courier company in 1 week. So this is just in a single week. This is the weight of the parcels. So look at these weights. So the parcels that are between 30 kgs to 35. Please take note that in the class interval, the intervals are in weights. What weight? Remember, we were told about the weight of the parcels couriered by a courier company. It's so important to understand the scenario so that when you answer questions, you can answer based on what you understand from the scenario, just using logic. From 30 to 35, meaning those parcels that are 30 exactly and are more than 30 to 35, not 35 is not included. So that's anything that is 31, 32, 33, 34, but not 35 in this row. How many parcels do they have that are between these weights? 11 of them. From 35 to 40, 13 of them. From 40 to 45, 15 of them. From 45 to 50, 17 of them. From 50 to 55, 19 of them. From 55 to 60, 26 of them. From 60 to 65, 36 of them. So now the question that is being asked is saying complete the table on the diagram sheet and hence calculate the estimated mean. They want us to calculate the estimated mean, but before that, we need to do what? Complete the table on the diagram sheet. Now, I wonder if I have that table. Let's see if I have that table. Maybe I do, maybe I don't. If I do, great. If I don't, oh, sweet. There it is. Okay. And these guys had actually even provided, sorry, you see, they had even provided for me for box and whisker, but it's fine. Freestyle. Okay, we saw the essence of what that box and whisker entails. So complete the table on the diagram sheet. So let's fill in the frequency values. We had 11, 13, 15, 17, 19, 26, 36. Then remember, they want the total. So what do? We take our calculator and then we add the totals. We have 11 plus 13 plus 15 plus 17, right? Plus 19 plus 26 plus 36. We get 137. That's the total frequency. Very important to have the total frequency, 137. Thank you very much. Midpoint. Now, what is that? When you look at your class interval, guys, okay, this is 30. This is your lower bound or your lower limit. 35, this is your upper bound, or they say your upper limit for your class interval. A class interval always has a lower and a upper. So to find your midpoint, all you simply do is you take Mr. Lower, you add Mr. Upper, you divide by 2. So that's what you are going to be doing consistently. So 65 divided by 2. So you go there to a calculator and you say 65 divided by 2. And then you press ST. You get that value. Okay. I don't know if that makes sense to you guys. Okay. That's what we do. Okay. So I am actually going to leave my answers as those fractions. We have what is it? 30 plus 35. Then you divide that by 2. Sorry, there we have it. It's 32,5. Okay, I think my calculator was doing funny things before that. So we have 32,5. Okay, that's how we find the midpoint. Someone asked in the comment section, how do we find the midpoint? You do that all the way. So 35 divided by 40. I'm sure you know the answer to that. Divide by 2, guys. We add, divide by 2. So I'm waiting for you guys to give me the next answer and the next answer and the next answer and the next answer. We divide by 2. We add, we divide by 2. Thank you, Coco Ban. 37,5. Coco Ban, you are the best. 40 plus 45 divide by 2. I'm waiting for those people to give me the next one. I'm sure you can see the pattern. 42,5. 47,5. You see, it's like this pattern that is there. 47,5. 52,5. I'm not even using a calculator. 57,5. There's this pattern that I'm seeing. 50, 62.5. So those are my midpoints. Then here we have the frequency times the midpoint. So now you need to take your calculator and multiply the two, frequency and midpoint, so that at the end we can get what we call our frequency times midpoint total. So what we are going to do now is we're going to do that exercise. Take 11, multiply by 32.5 and get our frequency times midpoint value. Okay, so I'm sure you guys will do that very handsomely for me. I'm going to just do the first one at least, and then the rest I'm expecting you guys to help me out very nicely. I confirm you guys, Coco Ban, Wango, you are right. 357.5. Give me the rest. Okay, I'm waiting. 357.5. Let's do the rest. The next one. $13 times 37.5. Okay, I trust Naledi, I trust Coco Ban. Next, 15 times 42.5. 15 times 42.5. Thank you guys. 637.5. Nice. Next, 17 times 47.5. You guys are phenomenal. Those calculator skills means we're going to have some amazing accountants in the future who are not going to miscalculate people's money, who will uphold the utmost integrity. 807.5. Let's go. Next, 19 times 52.5. Your Coco Ban is like stamping through those numbers, eh? Could it be that accountancy is calling you, Coco Ban? Okay, next, 26 times 57.5. Aye, Coco Ban, you're doing the most. 26 times 57.5. Oh man, Coco Ban is killing me in the comments, killing me in the comment section, stamping through the numbers. 1,495. Oh, look at that. Look at that. Mimi is doing the most too. Right. And then what we then want is also the total. So let us add all of these values. 350. We add all of them, guys. We add everything that you have there. Everything. 357.5 plus 487.5 plus 637.5 plus 807.5 plus 997.5 plus 1,495 plus 2,250. Please grace me with the total, guys. I have my frequency total. All I need now is the frequency times midpoint total, so that we are set and good to go, so that we can answer the question that was initially asked. Okay, I see Coco Ban has given us an answer. Let's just check if everybody else is in the same page as far as that value. Oh, Mimi has just confirmed it beautifully. Okay, I think in the mouth of 2 or 3 witnesses, words are established. Guys, didn't you leave the decimal there? Okay, I think you left it. 7,032.5. Okay, so here, guys, is what I have, which is called the frequency total. It's 137. Here I have the frequency times midpoint total, which is 7,032.5. Now, what I want is the mean. The mean, but more specifically from what we were told. We want the what? The estimated mean. Why do we call it the estimated mean? Guys, because this is not the actual mean. It is an estimation. Because remember, guys, even with this, we've not said what are the actual weights of each item. There's 11 of these items that are between 30 to 35, but we have not indicated what each parcel that is here, all 11 of them. We have not indicated here what are the individual weights of each parcel. All right, we have generalized that between 30 and 35 there are 11 of them, and we don't know the actual for the 11, if that makes sense. So when we calculate the mean, we are dealing with an approximation, an estimation, something close to what the actual mean would be. So that's why we call it the estimated mean. It's an approximation. Okay, so if I want to calculate then the mean, it's the estimated mean, because they said complete the table on the diagram sheet. Guys, completing the table is of utmost importance. And please guys, I'm using a pencil, but when in the exams you're not going to use a pencil. Please don't do that. Yeah? So we've added the frequency, and we've added the frequency times midpoint. So to calculate then the mean, the estimated mean, our estimated mean, guys, is simply the frequency times midpoint total over the frequency total. That's what it is. Okay, and then we will simply substitute the beautiful values that we were able to get, which is 7032.5 divided by 137. Then you punch that into your calculator, then you tell me what the estimated, please guys, that's what it is, the estimated mean is. What is the estimated mean? All right, it is 51.33. Seems like 51.33 is receiving popularity. It's 51.33. Now take note what the estimated mean is. Okay, any questions about that, guys? So what do we do when we are calculating estimated mean? We have to first find the midpoint and the frequency times midpoint, so that from the frequency we can get the total, and from the frequency times midpoint we can get the frequency times midpoint total. Then after that we proceed to calculate. Now lady, don't mind what the paper is. I'm not going to tell you squat about the paper. I'm just interested that you understand the concept, but because whatever paper you write tomorrow, guys, maths grade 10 maths paper 2, that paper, it will be a unique paper to your situation, where now you must understand the concepts. That's why I started off this revision by first going through the content that we are supposed to know for statistics, so that we have a good idea of what's happening. We together? The next question says, what is the modal class? By the way, I know I've got my 4 marks in the back. What is the modal class? Go back to the concept. Remember, I said when I was doing the notes, modal class is the interval with the highest frequency. Modal class is the interval with the class interval with the highest frequency. So if you look here, 11, 13, 15, 17, 20, 19, 26, 36, which interval has the highest frequency here? This is the highest frequency. Which interval has that? It's this one. But please guys, when you write down that interval, make sure you write it exactly as the inequalities you have here up here. Okay, I don't know. Okay, I think, let me just check that. Maybe that could have been an error, maybe, but it seems like this class interval is including both 60 and 65, and that is basically how it was produced to us. Okay, so we write that interval exactly as you see it, guys. We don't know deviations. We simply go ahead and we say 60, x is greater than or equal to 60 but less than or equal to 65. That is the modal class. What if they had said, what is the estimated mode? Remember guys, What would we have answered had they asked the question, what is the estimated mode? Let's go back to the note. Estimated mode, the midpoint of the interval with the highest frequency. The what? The midpoint of the interval with the highest frequency. That is estimated mode. The midpoint of the interval with the highest frequency. So, the interval with the highest frequency is this one. What is its midpoint? 62,5. So if they had asked me what is the estimated mode, this is the estimated mode, 62,5. That's what I would have answered had they asked what is the estimated mode. Here in this question, they asked what is the modal class. So you identify the class with the highest frequency. But if they had asked what is the estimated mode, you write down the midpoint of the modal class, which is obviously the midpoint of this class, which is 62,5. Last question. In which class interval does the median lie? Taurus, we just finished answering that question. The question you are asking, Taurus Han, had they asked what is the mean, the estimated mean, we just answered that question, which was basically 2.1. Okay. And how we answered that question? Taurus, you can't calculate mean for grouped data. You can't calculate the actual mean for grouped data unless they reveal to you the 11 parcels that you have here. What is their individual weight? Then you list the kgs that each individual parcel has, the 11, the 13, the 14, all of them would have to be listed. Now, can you imagine 137 values of weights? We would have to have the individual, values of each weight. All 11 of them would have to have the specific values between 30 and 35 for each individual parcel. All right, we don't have that. Therefore, for grouped data, we can only but provide estimated mean. Why? Because we don't have the individual weights of each individual parcel here. Okay, I hope it's clear, Taurus Han. If you call yourself a Taurus Han, then hopefully your Hanness is manifest in the beauty of your mathematics. That's very key. The beauty of your academics. A proper maths academic Han. That's what I'm talking about. Okay. 2.3, guys. In which class interval does the median lie? In which class interval does the median lie? Okay, now let me ask you guys, how do you find that? How do you find the class interval where the median lies? Maybe you guys have an idea. Grade 10 learners. My grade 10 learners, how do we find the interval where the median lies? You may find grade 11s being around here and grade 12s being around here, because grade 11s know fully well that this is also part and parcel of what they do. Grade 12s also know these are the basics, part and parcel of what they do. You only have this. You still are yet to learn more in statistics. Right? So in order to find the interval where the median lies, we take the frequency, guys. You see this frequency? We must take it. And then what do? We take that frequency, we divide it by 2. Now I want you guys to tell me, what is the answer that you get when you say 137, the total frequency, and you divide it by 2? What do you get? What's 137 divided by 2? Hopefully you get a nice, beautiful answer, which is what? Yeah, 68,5. Thank you very much. So take note of step one. Step one, if we want to find the interval, remember median means midway. We want to find the interval where the median would be situated. So why am I saying 137 divided by 2? Because that gives me midway of my frequency, halfway of my frequency. Does that make halfway? Make sense, guys? So step one, I take the frequency, I divide by 2. Step two, come to your frequency, add the frequency in a add the frequency in a cumulative fashion. Now some of you are going to be like, what is this guy even talking about? Add the frequency in a cumulative fashion. Take note what I mean. What's 11 plus 13? What's 11 plus 13? It's 24, right? Thank you very much. What is the 24 that you got plus 15? What's 24 plus 15? Let's continue. You see now I've moved, I'm here. 24 plus 15. 39. Thank you. Hold it. 39. Let's add 17. What's 39 plus 17? We're taking what we got, we're adding to that to 17. 39 plus 17. Yes, 39 plus 17, oratile, wango, mimi and naledi, 56. Now, listen. As I am getting these values, I am checking. Okay, so as I add these values in a cumulative fashion, I am checking, when do I reach? Because the minute I reach 68,5, or the minute I slightly exceed 68,5, that's when I am going to stop and check the class interval where this value reaches or slightly exceeds. Now, let's go back, guys. Remember, we said 11 plus 13, we got 24. 24 plus 15, we got 39. 39 is still far away. We are not there yet. 39. 39 plus 17, we got 56. We are not there yet. So we continue. Do you see? Because what do I want? I want to either reach. If I don't reach exactly, then I need to slightly exceed. I just need to immediately exceed. Not exceed further, but slightly exceed this value. So here we are having 56. What's 56 plus 19? What's 56 plus 19? 56 plus 19? 75. Guys, we stop right there. That 75 is when I begin to exceed this value slightly. Unfortunately, there was nowhere when I was adding cumulatively where I got here to 68,5 exactly. But when I got to 19, that's where I began to slightly exceed 68,5. So that means I check that class interval. That is where our median is going to potentially lie. It's going to lie here, right? Between 50 and 55. I'm going to repeat the process. So what did I say? Step one, find the frequency that's total divided by 2. Get the value. So that becomes your measure. Then you go to your frequency, you begin to add your values in a cumulative fashion. This 11 plus 13, and then taking 24 and adding to 15, you get 39. Taking the 39, adding to 17. That's what we call adding in a cumulative fashion. it's accumulating. We're accumulating, adding the value upon value. So 11 plus 13 is 24. 24 plus 15 give 39. 39 plus 17 give 56. We are not there yet, so we still continue. As long as we are not there, here, we continue. 56 plus 19. Whoa. We get 75. We stop right there because that's the minute we begin to exceed slightly. We stop where we slightly exceed, and then boom. What is that interval? It's this one. So this, guys, is the interval where the median lies. In grade 10, you get asked the interval where the median lies. And this is how you locate that interval. Okay, I hope we are good, guys. Are you hearing me well? Can I just get W's and the amens and hallelujahs in the comment section if we are good? If not, you can say, oh no, so that I know that me say I don't know what you are losing me completely. You are speaking alone. Just solid. I'm sure you just came in when that's why you are asking what you are asking. We don't need in grade 10. I think ghetto. It's either you are in grade 11 or 12. You are asking that question because you're in another grade. I'm dealing with grade 10 here. We are interested in finding the interval where the median lies in grade 10. And in the event, my grade 10s, they ask you for the estimated median. You see, I'm not saying the median, but if they ask you for the estimated median, do you know what you can do? You will go to that interval where the median lies. You will add the values. And what will you do? Divide by 2. So in other words, you get the midpoint of that class interval where the median lies. That is what your estimated median will be. The interval where the median lies, you use that, you find the midpoint of that class interval, which in this case is 52,5. That would be your estimated median had they asked that kind of question. Can you feel me? Can you feel me? Can you feel this, guys? Stats. Okay, guys, that's as far as I can go with stats. Okay. Now, remember, I said stats, that is one of your topics. You guys will make sure that you practice more question papers, you discover other questions, and you have fun with that. Analytical geometry. Easy marks. Analytical geometry. Easy marks, right? I hope we know it's easy marks. 1. Distance formula. We know most analytical geometry is a what? It's all about coordinates on a what? On a Cartesian plane, your y and your x-axis. Okay, so we have what we call the distance formula. Okay, that is the distance between 2 points. It's given by x2 minus x1, y2 minus y1. That's how we calculate. That is the formula for distance. Okay, usually they use d. All right, obviously AB, this is to imply that it's between point A and B, but I mean, guys, you get the point. In other words, the distance between 2 points on a Cartesian plane can be calculated using that. 2, gradient. y2 minus y1 over x2 minus x1. Let's not ever, guys, swap the formula, the change of y over the change of x gradients. That's the second formula you need to know. Second to that, under gradient, you also need to know the following. This is very important. Under gradient, you also need to know that for parallel lines, if this is line 1 and this is line 2, parallel lines have equal gradients. So the gradient of line 1 will be equal to the gradient of line 2 for lines that are parallel. Parallel lines equal gradients. Parallel lines equal gradients. Parallel lines equal gradients. Then for perpendicular lines, line 1 and line 2. What do we know about perpendicular lines? The product of the gradients gives us -1. If line 1 is perpendicular to line 2, in other words, these two lines, they intersect at 90 degrees, then we know that the product of the gradients should give us what? -1. Okay. That is very important under gradient. The other thing that is very important is collinear points. What do we mean by collinear points? Collinear points are points that lie on the what? On the same line. What do we know about points that lie on the same line? Obviously, if it's a straight line and all these points lie on this line, we know that the gradient of this line is the same throughout this line. So in other words, it means that for collinear points, if A, B, and C lie on this line, then we know the following, that the gradient of AB, so from A to B, the gradient of AB is equal to the gradient of BC. And in actual fact, not just that, but it's also equal to the gradient of A all the way to what? To C. So if points are collinear, if they say to you, ABC is collinear, then you are to understand that collinear points have equal gradients. So these are important concepts underneath the concept of gradient. When you have these concepts very well understood, then you are the main man. You are the main guy. You are the main guy. Take note of this as well. A line like this is an increasing line. Its gradient is positive. A line like this is a decreasing line. Its gradient is negative. A line like this that is horizontal has a gradient that is equal to 0. And lastly, a vertical line like this has a gradient that is undefined. Very important that we understand all of this under the concept of what? Of gradient. Gradient, the formula. Parallel lines have equal gradients. Perpendicular lines, the product, the multiplication of the two gradients of these lines should always give you -1. Collinear points, point A, point B, point C. If A, B, and C lie on this line, then it means that the gradient of the points that form the lines are equal. That's why we say gradient of AB is equal to the gradient of BC. And in actual fact, we could also say they are all equal to the gradient of AC. And then lines, a line like this has a positive gradient, a line like that has a negative gradient, a line that is horizontal has a gradient that's equal to 0, and a vertical line has a gradient that is undefined. All of this is of great help, because when we need to find the equation of a straight line, the equation of a what? Of a straight line, we need to have gradient. And oftentimes, if we have points, we can calculate gradient using that formula. If we have points and apparently there's a line, but it is parallel to another one, we have the gradient of this line, but we don't have the gradient of this line, but we want the equation of this line. Because these lines are parallel, we know that we can state what the gradient of this line is, because if we know the gradient of this line, for parallel lines, the gradients are what? They are equal. So we use these things whenever we are given questions where we are told the equation of a line is the equation of another line we do not have. What is the equation of that line? Then we say analytical geometry, analytical geometry is fun and it's easy. The third thing that we need to know under analytical geometry is key midpoint ntwe. Kwi midpoint ntwe. Okay. Midpoint wahlalukhanya. If you have A, you have B, and apparently, okay, take note, some symbols that would indicate that M is a what? Is a midpoint. MB on this line, on the same straight line, is equidistant to AM. The distance from A to M is the same distance from M to B. So we call this the midpoint. If we have the coordinates of the endpoints, if coordinates of the endpoints, now in this case, guys, the endpoints would be A and B, the points at the end. If the coordinates of endpoints are given, okay, we can simply find the coordinates of M by doing what? x1 plus x2. Which x1? The x coordinate of A plus the x coordinate of B over what? Over 2, to find the x coordinate of the midpoint. The y coordinate of A plus the y coordinate of B divided by 2 to find the y coordinate of the midpoint. That is how we are able to find the midpoint. So in summary, guys, these are the concepts that underline analytical geometry in grade what? In grade 10. Distance formula. And the questions around distance formula have to do with finding the distance between 2 points, or you get given the distance and they ask you to find one of the points, either the x or the y value of a certain point. Okay? Or under the concept of equidistance, they may ask you to find or to calculate a missing point. Then there's gradient, and I've looked, guys, I've explained to you to a great degree some of the concepts that underline gradient and what are some of the possible things or scenarios that we can see under gradient for parallel lines, perpendicular lines, collinear points, and then just a general understanding of the direction of a line and what we can expect from the gradient. Okay, someone is trying to be hot outside with the car. Y is equal to mx plus c. How to find the equation of a straight line? We know we need the gradient and we need the y-intercept. We call these guys, this c value, we call it the y-intercept, where the graph cuts the y-axis. There we know that x is equal to 0. The y-intercept is the line where x is equal to 0. So the c value is the y value for the y-intercept, okay? But x is always going to be what? 0. And then midpoint, okay, you can be given questions where you are asked to find the midpoint, or sometimes you are given the midpoint and they ask you to find the endpoint. Given the midpoint, then asked to find endpoint. So we need to be people that are in the position of being able to find the endpoint if the situation warrants. Okay. Then the last thing I want to touch on is this quadrilaterals. My beloved, amazing grade 10s. You need to understand the properties. Okay, in grade 9, they tried to hammer in the properties of the quadrilaterals with you. They tried. In grade 8, they tried to hammer in the properties of quadrilaterals. You are in grade 10 now. You should be the master. Okay, you should be the master of quadrilateral. Not only that, guys, triangles as well. You should be someone who understands the properties of all different types of triangles if you are a grade 10 learner. Okay. With triangles and quadrilaterals, obviously, there comes area and what? And possibly perimeter. You must be people that know the area of all triangles. If asked, you must know the formula. You must know how to apply it. You must be people that understand the properties of triangles, but also you need to know area and perimeter. So for instance, for triangles, if I say, what is this type of triangle? You tell me now, what is this type of triangle? What do we call this triangle? And what is unique about it? What is this triangle called? And then you must know what analytical methods to apply to prove a triangle like this. Yes, guys, this is isosceles. Okay. Its angles are always opposite what? Sides that are equal. Okay. And they usually can ask you questions, give you a triangle in a Cartesian plane. It will have points, and then they'll say to you, prove that this triangle is an isosceles triangle. Okay. So that means if they ask you that, to prove that that is an isosceles triangle, and you have the 3 points on the vertices, you can use distance formula. You calculate the distance from here to here using the distance formula. You calculate the distance from here to here. You calculate the distance from here to here. What should be there at the end? You should find 2 sides. 2 lengths from your distance should be equal, and the other one should be unequal to the 2. Then you can conclude, therefore, this is an isosceles triangle. What is the reason? Angles, 2 sides of a triangle are equal. That is why. By using the distance formula, guys, you see? So that's how you apply analytical methods to proving triangles. That's why I'm saying to you guys, know the properties. Okay, what type of triangle is this? It's an equilateral triangle. Okay, and as a grade 10 learner, an equilateral triangle has 3 equal sides. Same thing. You can use the distance formula. If they ask you to prove, is that an equilateral triangle? Then your responsibility is to use the distance formula, calculate the distance here, calculate the distance there, calculate the distance there. If it is an equilateral triangle, what should you find after calculating your distance? You should find that all your lengths are equal. What type of triangle is this? And this one is very famous in analytical geometry. What type of thingamabob is this? Okay. It's a very scary creature that usually lives in the corner of your house. It makes holes. Okay, it's a rat, guys. It's a rat. Very scary creature, this one. This is a rat. Right angled triangle. It's a rat, guys. So how do you prove using analytical methods that a triangle is a right angle triangle? You see, these are important things, guys. And maybe you can say, you can use distance formula as well here. Calculate the distance here, calculate the distance there, calculate the distance there. You check the side that is opposite 90 degrees. You know that will be called your what? Your hypotenuse. Take that side. Take that side and square it. Then you check. If you take these 2 sides, you add them together whilst squaring them, do the sum of the square of these two sides equal this side? Because if they do, then this is a right angle triangle. Kaloku, a right angle triangle would actually mean that the square of the hypotenuse should definitely be equal to the sum of the square of the other two sides. You always know your hypotenuse side because it's always opposite the 90-degree angle. So check squaring this side, what do you get? After that, you go and square these two sides, add them together, and then you check, do the sum of the square of these two sides give you the square of that side? If it does, then it means this is a right angle triangle. All right, you take your longest side. I think that's what I wanted to say, because you wouldn't know at the beginning that it's a right angle triangle because the 90 won't be there. You will be given just this triangle. But what you do, you take your longest side, you square it. You identify your longest side after using the distance formula. You square that side, and then after that, you square you square these individual sides and you add them together and you check. If that total does not give you the same square of the longest side, if it does, then this is a right angle triangle. That's why I'm saying to you guys, understand the different types of triangle. What type of triangle is this? Grade 9 learners that are here, hopefully you are taking a sneak preview. I'm planning to have a summer sort of like situation with the grade 9s in the holiday. Prepare them for grade 10 before grade 10 starts so that they can start off in a bang. Yes, this is a scaling triangle. So how would you prove that a triangle is scaling? Distance formula again. You should find that all three sides are not equal. If they are not, you conclude, therefore, triangle ABC is a scaling triangle. Reason, all three sides are unequal. You see? Okay, I hope you guys are getting the point. Area of a triangle, guys, is half base times perpendicular height. So it becomes important that if the triangle is an acute angled triangle, then the perpendicular height should be internal to the triangle. At the foot of the perpendicular height, what do you have? You have what we call the base. This formula, if you are calculating area, needs the distance of the height that is perpendicular. Guys, this is grade 10. Okay, this is grade 10. So if all these people from other grades are coming through grade 11 and grade 12, the grade 10s have not learned all these other things. So chill. All right, this is a grade 10 lesson. So we have limitations. We have learned up until a certain extent. So half base times height, perpendicular height is all that my beloved grade 10s know. Okay, the rest they are going to learn next year in grade 11. So its area is equal to half base times perpendicular height for my beloved grade 10s. So you need the distance of the height that is perpendicular, and then you need the distance of the base so that you can do what? Plug it into the formula and calculate area. Perimeter is straightforward. What is perimeter? It's the total distance around a two-dimensional shape. So it's a matter of having the distance from here to there, distance formula, from here to here, distance formula, from here to there, distance formula. You add those together. Voila, perimeter. Are you gaining something? Okay. Grade 10s, quadrilaterals. Yo. Okay, so for analytical geometry, it's also important, guys, under analytical geometry to understand the quadrilaterals, all of them. Okay, I'm not going to cover everything here. Thank you so much, Joyce. I appreciate the rose. I appreciate it so much. You have no idea. Thank you so much. Parallelly, equally, diagonally bisect each other. Okay. Okay, angles, opposite angles are equally. Sometimes you get asked to prove that something is a parallelogram. Guys, let's not waste each other's time. The quickest and shortest method that you can use to prove that a quad is a palm, you simply use midpoint. Midpoint is the quickest, it's the shortest, it is the quickest. Okay, and that is coming from the concept of diagonals bisect each other. For analytical geometry, to prove that a quad is a palm, the quickest method is to basically use your endpoints and find the midpoint. So what you do is you use these endpoints, okay, for this diagonal, you find the midpoint. Then you use these endpoints, you find the midpoint. If the midpoints are the same, you then conclude, therefore, ABCD is a parallelogram. What is the reason? Diagonals bisect each other. Done. One property using the midpoint. How many calculations do you do when you use the midpoint? You are going to find the midpoint most for this endpoint and this endpoint. Well, that's one calculation. Then you find the midpoint by using these endpoints. When you find that your midpoints for both calculations are the same, then you then conclude, therefore, quadrilateral ABC is a parallelogram, and then you write your reason. Diagonals bisect each other. Okay? Diagonals bisect each other. Okay? Ghetto the plug. I don't know if you're talking to me. All right? Unfortunately, I'm a father. I have kids. They are around. So, yes. Unfortunately, I cannot completely isolate myself from them. And they are around. So they do make that occasional noise. If it is really bothering you, I'm sorry. It's kind of like, unfortunately, I can't completely silence them. Okay. But we can't even hear you. Then ghetto, that's a bit unfortunate. Okay, because there's nothing more I'm going to do about that. It's an unfortunate situation. Then we have your square. Okay, I'm not going to go deep. You need to know how to prove that a quadrilateral is a square. You have your rhombus. You have to know how to prove that a quadrilateral is a rhombus. Better yet, how to prove a parallelogram is a rhombus. Sometimes you have to move from one to another, and they usually do that to ask and check. You need to know how to prove a quadrilateral is a rectangle. Okay, yes, I will. Don't worry, Lut. 5. As you have seen, I've posted the others. All right, I've posted the others. Then, of course, there is beautiful trapezium, who is straightforward. There's only one pair of parallel sides, so that is gradient. Find the gradient of the one and the other side if the two pairs of gradients are equal. If the gradient here and the gradient here are the same, then you say the pair of parallel sides. One pair of parallel sides, that is a trapezium. 6, beloved mystic height. Okay, beloved mystic height. And it's nice because all you do, you prove the pair of adjacent sides with a kite. So if you basically can use the distance, calculate the distance here, calculate the distance there, they are equal, calculate the distance there, calculate the distance there, you find out they are equal, you can conclude that this is a kite, and the reason is two pairs of adjacent sides are equal. Alright, guys, this is like crash course for analytical geometry. Crash course. You know what a crash course is? This is what I call crash course. So let's look at a few questions under analytical geometry, then after that we'll move to trig. Okay, I hope you guys are appreciating what I'm doing here, because what I'm doing here is I'm trying to help you guys first understand the concept. This is not like I'm not doing things randomly here. All right, I know you guys forget. You get taught by brilliant teachers at your school, but you guys forget, don't you? So in the diagram, OAFB, okay, that is a parallelogram. Guys, the minute they say it is a parallelogram, it means all the properties that apply to a parallelogram can actually be taken at face value. You see? So for instance, if you look at OAFB, what you notice about it is that there's no other things that are inscripted there, but besides the fact that we are told in words that OAFB is a parallelogram. AGBF, and AEBF are what? Are also quadrilaterals. We are not told what kinds of quadrilaterals they are. We just know they are quadrilaterals. So we just take it like that. O is the origin. Guys, every time they say to you, O is the origin, please do yourself a favor and go right next to that O, the coordinates of O, which are 0 and 0. Too many times when learners are told that O is the origin, they don't take into consideration the fact that that means the coordinates there are 0 and 0. So you look at all the other coordinates you've been given, but you actually forget to know or accept that the coordinates there are 0, 0. Okay. O is the origin, and G, O, and B. Where's G? G, O, and B, we are told are what? Are collinear points. They are what? They are collinear points. We learned something about collinear points. And what did we learn about collinear points earlier on? That collinear points, obviously the gradients between collinear points, the gradients are equal. Then lastly, the diagonals, what? Of O, A, F, B are perpendicular. The what? The diagonals, here they are. They are perpendicular. You can see the 90 degrees. That's indicating perpendicularity. These coordinates we were not told about in the statement, but because the diagram has these coordinates, it means that those are coordinates that are supposed to be utilized in our calculations. Does that make sense? Yeah. No. So O is 0 and 0. It is the origin. Please guys, be very careful. The fact that G, O, and B are collinear points means that the gradient of GO is equal to the gradient of OB. Okay? And the gradient of GB as well. So nothing about the fact that O is 3 and -1. It can't be that, Henny. Be careful, ne? Be careful. The question says, determine the coordinates of M. Something else to note, guys. Look at E and B. X is -2, X is 3 here. Y is -1, Y is -1 here. This means that this is a horizontal line. Alright, because the Y values are the same. They are constant. So that means this is a horizontal line and the gradient of this line is 0. I know that because of the fact that I can see the coordinates as the same. Question says, determine the coordinates of who? Of M. How do I determine the coordinates of M? What is M? In the statement, I'm not told anything about M, but we were told that OAFB are what? Is a parallelogram. So if OAFB is a parallelogram, what is M, guys? What do we call M? Because this is FO and this is AB and these are diagonals. What do we know about the diagonals of a parallelogram? Okay, we know that the diagonals bisect each other, therefore M is a midpoint. Very good. You guys are 100% correct. I love this. So when they say determine the coordinates of M, I can, with authority, okay? I'm just going to put in those things. I can, with authority, use the midpoint. Okay, which coordinates can I use? I can use A and B if I want. Or remember, I told you this is O, the origin. I can use O and F. I should get the same answer either way. Okay, Tseho in the comment section is saying the coordinates are 2 and 1. All right, 2 and 1. Let us check. If I use, guys, the coordinates of A, which is 1 and 3, and B, which is 3 and -1, then it means x coordinate of A plus the x coordinate of B divided by 2, the y coordinate of A plus the y coordinate of B divided by 2. I can substitute the x coordinate of A, which is 1, plus the x coordinate of B, which is 3, divide that by 2. Y coordinate of A, that's 3, plus the y coordinate of B. So that means 4 over 2. That means 3 plus minus 1 is 3 minus 1 over 2, which is 2 over 2. That's 2. Ne? And that is 2 and 1. So that is M. That's very much correct. Let's check if we use the origin. O and F. O is 0, 0. That's the endpoint. And F is 4 and 2. What if I decided to use those coordinates instead? Would I be able to still get the answer? Let's check. M, the x coordinate of O plus the x coordinate of F over 2. The y coordinate of O plus the y coordinate of F over 2. The x coordinate of O, 0 plus 4. The y coordinate of O, 0 plus 2. So that is 4 over 2 with 2 over 2. Seems like, guys, I still get the same answer, 2 and 1. Those are the coordinates of M. So either way, all right, this is not to say you do both calculations, you just do one. But I was just showing you guys that whether you use this one or this one, it doesn't matter. Okay, please don't do both calculations, because the question was just saying determine the coordinates of M. All right, and so we were able to just confirm whether we use this line or that line doesn't really matter, because these are the endpoints for O and F, and these are the endpoints A and B for the midpoint M, and it works either way. Let's go on. 3.2. Why can OAFB be classified as a rhombus? Remember, OAFB, we are told, is a parallelogram. But now, why can we classify OAFB as a rhombus? Now, this goes back to something very important that we need to note about the properties of a quadrilateral. Okay. If the diagonals of a quadrilateral bisect each other, we can say it's a parallelogram. But if those diagonals don't only bisect each other, but they bisect each other at 90 degrees, then we can elevate the status of this OAFB from being a parallelogram to a rhombus. Let me repeat what I just said. We initially were told that OAFB is a parallelogram, but the diagonals of OAFB are also what? Perpendicular. So if the diagonals are what? They are bisecting each other, as you can see. OM is equal to MF and AM is equal to MB. That is what bisect means. And 2, they actually bisect at 90. In other words, they bisect perpendicular. Then we can conclude that that is a rhombus. So why can OAFB be classified as a rhombus? OAFB is a parallelogram. Okay, already. Yeah? But what kind of parallelogram? It is a rhombus Why is it a rhombus? Because it is a palm. Because the diagonals bisect at 90 degrees. This is what adds flavor to this parallelogram becoming a rhombus. It's the fact that the diagonals bisect at 90. The diagonals are perpendicular, additional to the fact that it's a parallelogram. They bisect at 90. So when you have a parallelogram that has diagonals that bisect at 90, it's no longer a parallelogram, but it is a what? It is a rhombus. So that's why. It's as simple as that. Diagonals bisect at 90. That's why we say it's a rhombus. Okay, a parallelogram that has diagonals that bisect at 90 is called a rhombus. Let's move on here. Grade 10, guys, this is grade 10. Prove that AOBF is a square. Prove that AOBF is a square. Where is A? There's A. Where's O? There's O. Where's B? There's B. There's F? There's F. How do we prove that AOBF is a square? Now, remember, we've already proven, first and foremost, that OAFB is clearly a rhombus. What can assist us to prove that now that it is a rhombus? How can we move from it being a rhombus to proving that it is a square? Okay. We can use the adjacent sides. How? If we can find out that this angle here is 90 degrees, in other words, AO is perpendicular to BO, then that's enough. All right, because a rhombus that has adjacent sides that basically intersect at 90, adjacent sides that basically make an angle of 90, adjacent sides that are perpendicular, that would elevate our rhombus to becoming a what? A square. So what are we going to do now with our calculation? We are going to come here and find the gradient of OA. And after that, we are going to find the gradient of what? Of OB. Then after that, we are going to multiply these two gradients and check, do we get -1? Why am I going to check if I get -1? Remember that the product of the gradients, if it gives me -1, then it means that OA is perpendicular to who? To OB. That will elevate the status of the what? Of the rhombus to becoming a what? A square. So I'm going to repeat what I just said. I am saying to you guys, remember initially we were told that OAFB is the parallelogram. We are together then. Why? Because we were told it is. So therefore it means all the properties that apply to a parallelogram are to be applied to OAFB. Furthermore, we were then asked, why can we say that OAFB can be classified as a rhombus? So the question then is, how do we move from this OAFB being a parallelogram to moving it to becoming a rhombus? There's an essential characteristic of a rhombus that makes it unique, all right, and that elevates the palm to becoming a rhombus. That is when the diagonals don't just bisect, but they bisect at 90. So why is OAFB classified as a rhombus? It's because the diagonals, we could have just written this, the diagonals of OAFB are perpendicular, which therefore means that the diagonals bisect at 90. That is formal. We've gotten that down. Now we know that OAFB is actually now a what? A rhombus. Now the next question is saying, prove that AOBF, which is the same shape here, is a what? Is a square. So my question then is, we've proven that it's a rhombus already. Okay. Now, if it's a rhombus, it means these four sides are equal. That's one thing. The diagonals also bisect at 90. That's another thing. But what can make this thing OAFB to become a square? We know that a square has corner angles of 90. So if I can come to this square, to this rhombus, because currently it's a rhombus, and then check the gradient for my adjacent sides. Let's check the gradient of AO, calculate it, find out what it is, write it down. Calculate the gradient of OB. You have the coordinates, calculate it, find out what it is, and then you multiply the two gradients and you get an answer of -1. What would that mean? If you multiply the two gradients of AO and OB and you get -1, what does that mean about the angle formed between these two adjacent sides? It means that AO is perpendicular to OB. Therefore, this is 90. So a rhombus, guys, that has corner angles of 90 is no longer just a rhombus, but now it has elevated its status to becoming a what? A square. I've explained it the second time. Are you guys with me? Are you hearing me? So did we calculate the gradient of, or if we don't want to calculate the gradient of these adjacent sides, we can do the gradient of AF and FB. Okay, you don't necessarily have to do these ones. You can look at another pair of adjacent sides, calculate the gradient of AF, calculate the gradient of FB, and then you multiply those gradients and check, do you get -1? If you do, then it means angle AFB is 90 degrees. Therefore, okay, if that is 90, guys, remember for a rhombus, opposite angles are equal anyways. So if that is 90, that would mean that's also 90. I don't have to check the gradient of the pair of the sides and multiply and then do the same this side. No, I just need to check one pair. That's enough. And then the conclusion will then be that A of B is a square. Why? Because it is a rhombus that has a pair of adjacent sides that are perpendicular, because the corner angle is 90. Kaloku, a rhombus that has corner angles that are 90 is no longer a rhombus, but it is a what? It is elevating its status to become a square. All right? So it's like we're elevating the status here from parallelogram to rhombus to square. Okay, guys, I am not smart, right? Yeah, I am not smart. And I know, and I'm not saying this just because I am saying it, it's the honest truth. Me, I've just, like you would, okay, if you would spend some time, do this for a very long time, you would also become someone who understands it in such a way that you can actually relate and explain it to someone else. So that's nothing special, it just means I've spent more time with it. I want you to also spend a little bit more time with it so that you can get your marks, the marks that you deserve. It's not enough to just come for a revision session the day before. You must be someone that plays the game. Maths is a game. You play it every day. You get better at it. You know how you play a game and you gradually get better and better the more you play it? That's what I mean. Okay. So did you guys get the gradient of AO? I'm not going to do this problem, but I can see the gradient. 3 minus 0 at the top in the numerator is 3. 1 minus 0 at the bottom is 1. So 3 divided by 1 is 3. So the gradient here is 3. If we calculate this gradient, -1 minus 0 is -1 in the numerator. 3 minus 0 in the denominator is +3. So this is -1 over 3. Now if I take the gradient of AO, which is 3, multiplied by the gradient of OB, which is -1 over 3, that gives me -1 straight out. I then conclude AO is perpendicular to OB. Then I conclude AOBF is a what? Is a square. What is my reason? The rhombus, all right, has adjacent sides that are perpendicular. Therefore, the corner angle is equal to 90. Full stop. Done. Proved. I've proved that AOBF is a square. Or alternatively, if you use these two sides, if you didn't use these ones, you could have used those sides. All right. Calculate the gradient here, calculate the gradient here, multiply the two, you get -1. You conclude that AF is perpendicular to FB, and then you conclude that AOBF is a square. Reason. What is the reason? Again, adjacent sides AF and FB are perpendicular. Corner angle is 90. Done. Done. A rhombus, guys, that has a corner angle of 90, all right, is a square. Today, quadrilaterals has to come back whether you like it or not. You see, this paper was just laced with quadrilaterals. So this one, I know maybe you've done other questions with other things. Okay? Simple questions, calculate the gradient, calculate the distance. I'm sure you guys can do all of those things. What I love about these questions, they are forcing us to remember what are the key things that we need and how do we use analytical methods to prove certain quadrilaterals. So here, show that AGBF is a trapezium. AGBF is a trapezium. So where's AGBF? AGBF. We need to show that that is a trapezium. So what do we need to show that a quadrilateral is a trapezium? All right. Remember, what is the special characteristic of a trapezium? Do you remember from my notes? Hey, me, guys, I'm kind to you. Then you use analytical methods. One property, one pair of parallel sides. Okay, so what do you use? What analytical method will you use to prove a pair of parallel sides? You're going to check gradient. Now, the question is, when you look at this shape, which potential gradients will you be looking at? Okay, which lines for A, G, B, F are you going to straight out plug into your calculator and calculate the gradient of? Okay, remember they said here in this statement that G, O, and B are collinear. So you are not given the coordinates of G, right? But you have O and B. So the gradient of O and B is a gradient that you can calculate. You can calculate that. If you had done so, calculating the gradient of OB in the previous question, then it's a matter of, in the next question, simply saying the gradient of OB is equal to -1/3, as proved above in the previous question, if that makes sense. Then all you do is simply calculate the gradient of AF. Or if you did not calculate this gradient, but you calculated this one in the previous question to answer this question, then of course you are going to say the gradient of AF is equal to 3, and then, -1/3, and then you are going to say as proved above, and then you calculate the gradient of OB. But what do you find, guys? When you calculate this gradient of AF, and then you calculate the gradient of OB, you get the what? You get the same gradient, don't you? Don't you get the same gradient? You absolutely do. You get the same gradient. 3 minus 2 in the numerator gives you 1. 1 minus 4 in the denominator gives you -3. So you have -1/3 for your gradient of AF. And if you remember here, you had the gradient of -1/3 as well. So you calculate those two gradients, then at the end you conclude, therefore, AGBF is a trapezium. What is your reason? Since the gradient of AF is equal to the gradient of OB, all right, then you can say that one pair AF is parallel to GB, and that is basically why you are saying AGBF is a parallelogram. No, not a parallelogram, is a trapezium. Oh, sorry guys, my language is a trapezium. Okay. And the very last question for this paper in analytical geometry was prove that AEBF is a guide. AE what? AEBF is a guide. Where's AEBF? AEBF is a guide. AEBF is a kite. So what we need here, distance of this, distance of that. I'm sure you'll find that the distance formula applied will give yield to something. Distance applied, this will be equal. Then at the end, what do you say? Therefore, you know, when these two AF and FB are equal and AE and EB are equal, then you can conclude that this here, AEBF, is a kite, and then you state two pairs of adjacent sides equal. And that's it. Okay, guys, it's 7 marks. It makes sense that it's 7 marks because how many calculations do you have? You have to calculate the distance formula here, distance formula here, distance here, distance there. And then you compare. You match the ones that are equal distance, then you conclude about the quadrilateral that it's a kite, and you give your reason. Okay? Okay. Just one more thing I want to say. What if they had said, calculate the area of trapezium AGBF? Calculate the area of trapezium. Are you saying this is a lot? You're my soul. So guys, I'm going to actually take a break now. I need to go make supper. I'm gonna come back maybe at 8 o'clock so that I can give you guys also a breather and you can kind of gather yourself, because I'm going to pick up from analytical geometry, do trigonometry, and finish off with Euclidean geometry. So this paper is a lot, but what is beautiful is that if you have solid understanding, it is not a lot. Okay? Yeah. Lady N, which year is he doing? I need to go look for it. I feel like he is complicating things. Wow, I am complicating things. You're kidding me. All right, 9 p.m. it is, and I'll come back at 9 p.m. because I need to bounce. Okay, I think that's as far as I'll go. Had they said calculate the area, the only reason why I think some of you feel like I am complicating it is because I don't think many of you have really internalized this concept of quadrilaterals. The question paper itself only asks you to determine the coordinates of M. They ask you for midpoint once, and the rest of the questions have to do with properties of quadrilaterals. So if you are not someone who is safe around that concept, then yes, it may feel like I am complicating things. Okay, I am complicating things. So what I'm going to do is I'm going to end this live here. I am going to download this video, go and upload it onto my YouTube channel. So those who need to watch this video that I've just done now of this live session, they want to see how I did the stats, how I was able to navigate both through grouped and ungrouped data, all these concepts around all these other things, then those people need to go and check those out. Livia, I'm glad that you can see that you are terrible at remembering properties. Now the thing is, that's why, okay, I don't know if any of you are in your room. If you are in your room, let me ask you now to stand up, go and switch off the lights in your room. Okay, now I'm going to give you 10 seconds. I'm hoping you are standing up from your bed, you are putting down your phone, you are switching off the lights in your room. How does it feel? It's dark, right? Do you like that feeling of it being dark? I don't think so. I don't think so. I don't think you like that feeling of it being dark. Okay, switch on the lights. Okay, after it's already load shedding. Okay, Lunga Lubelo, you have like the joy of just being in the dark by virtue of being in the dark. YouTube name, Maths is a Game. It's the same thing. Maths is a Game. That's the YouTube name. If you want to find the link is in my bio. Maths is a Game. You can copy the link, you paste it on your Google search engine, and then you press search. All right, copy the link from the bio. Okay, not the WhatsApp channel, but the YouTube link. You copy that link, you paste it on your Google search engine, and then it should lead you to the YouTube channel. You subscribe, and then I will, like I said, will upload this video. It's gonna take a while for it to download, but then I'll upload it onto the YouTube channel. You can check it out, and then I'll be back at 9 p.m. to finish off the rest. Okay, so you guys are in the dark now. As I said, when you switched off the lights, you switch on those lights again. You don't like the feeling of being in the dark, right? That's what happens, guys, when you don't know these properties. That's what happens. It's like you are in the dark. Then Mr. Examiner decides that you are going to write a paper where these properties are there, and they are asking you to prove certain things. Then you feel very despondent and hurt and at pain, and you feel like this is too much and all of that because you didn't devote some time. You know, so guys, whenever someone knows something, it's always nice. You have this good feeling when you know stuff, but when you don't and you are in the dark about something, it's not a great feeling. So what you want to do now, I want you switched on the lights now. Look at your wall. I'm sure you have a wall somewhere. There are posters that you've posted up on your wall. I know some of you are avid lovers of people. You have stuff on your wall. Maybe you have your favorite artist. Maybe you have your idol. Maybe you have, I don't know, whatever you have on your wall. Guys, stop posting up individuals that are not going to benefit you on that wall of yours. It's high time you start putting up content like all the properties. Why don't you design a poster and you post up that poster? Maybe you are a very colorful person and you love using bright and beautiful colors. Compile a poster. You are going to need to know these properties for grade 10, 11, and 12. Post them up on the wall, all of them, and then have them there so that you can always be seeing them. Okay, that goes for all things in mathematics or in other subjects that you might feel that you are going to forget. Academics, is that important to you? Getting good marks, is that important to you? Passing and getting great grades, is that enough for you? Maybe you want to break out of the stereo or the finance situation you find yourself in. Please, guys, do what needs to be done. Okay, please, 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 so that that content can move from your wall to your mind to your heart as you see it every day. So that's what I would advise. Guys, thank you so much. Thank you for joining the live. I will be back after at 9 p.m. to finish off. Here's Trig, guys. You see, Trig is waiting for you. Trig is waiting for us. All right, Trig is waiting for us. Yeah, but I will upload the video so that you can check this out. Thank you so much, grade 10s. It was great. So if you are in grade 10, great. I'm happy to have had you. If you're in another grade, it was great. It's great that you were here. Cheers, guys. Cheers. And thank you for those that gifted. I really appreciated that as well.